So today what I'm going to be doing is taking out a third wheel jewel in this Waltham grade 225 pocket watch, which I disassembled a few weeks back. So I've done my pre-cleaning and inspection on this watch, and what I found is that this third wheel jewel in a brass setting is cracked, and the way that might happen is someone's putting wheels in and then screws down the train wheel bridge without checking to make sure that all the pivots are properly located. So this jewel is cracked and it's going to have to be replaced. Now, this is an old type of jeweling setup in which the jewel is placed in a brass setting. It's rubbed into the brass setting, that is, the brass is folded over the jewel to hold it there, and then the setting is put in the plate. In this case, it's actually friction fit into the plate. There's no screws. These jewels are hard to find these days. They come with a particular thickness and a particular width. So what I'm going to do is I'm going to improvise what I think is an appropriate restoration technique here. So I'm going to take out this brass setting, and I'm going to make a new brass setting fitted with a modern friction jewel. So to remove the original brass setting, I'm just using the jeweling attachment to my staking tool. So it's got this handle here which screws on. It's got a little spindle or micrometer here, and I've got a punch set up, a jeweling punch, to just push out that brass setting. Okay, so that's what I'm going to do now. Just want to make sure it's appropriately centered. Punch is hollow, so it shouldn't be touching the jewel. It should just be riding the edge of the jewel, not the edge of the jewel, pardon me. It should be touching the edges of the brass setting, but not actually touching the main plate. I don't want to damage the main plate. So there we go. I've removed the jewel from the setting. Now what I can do is take some measurements. In particular, I want the external diameter, because I'm going to cut the new bushing the new setting to be of the same diameter. But I also want to take a measurement, and it might be a little bit of a rough measurement, of how much of the jewel is exposed on the side that you can see. Okay, so that means I can choose a new friction fit jewel that once it is installed will look the same as the other rub-in jewels. So before I proceed any further, I'm bringing you guys in for a close look at the third wheel jewel in its setting that I've just removed from the main plate. So you can see the jewel is cracked. The crack goes there are two cracks. They go all the way to the pivot hole. So this jewel will no longer hold oil properly, and we'll probably see a reduction in amplitude. So we're going to have to replace this jewel. As you can see, the jewel is fixed into a brass setting. So the jewel actually extends further than what you can see. So on this side, it's a wall of brass that it's pushed up against. This is the dial side. You can see the oil sink there. And on the back side, you can see how the jewel is fitted in. So there is an opening here. The jewel is pushed in, and then a little lip of brass is rubbed over the circumference of the jewel, just on the top side of the jewel, and that holds it in the setting. This is different from a modern friction jewel, and it's different from the setting that I'm going to make. So what I'm going to make is just a tube of brass, and I'm going to put in it a new friction jewel, which doesn't have this rubbing in, right? What the diameter of the jewel that you will see is the full diameter of the jewel, because it's just going to be friction fit into a hole. First the diameter. Two point two 2.27, I would say. Now the thickness 0.52, let's say. So this isn't going to be perfect, but I'm going to do it by eye. So I've got the dial side of the setting and joule up, just using my digital caliper here, and I'm going to get a rough idea of how much of the joule is exposed. I'm going to say about 0.95 of a millimeter. So I'm going to select a friction joule such that when I put it in a new brass setting, 0.95 of that new friction joule, i.e. the diameter of that joule, is going to be exposed. And that way, once I've got the new setting with friction joule in place, it will look very similar to the other rub-in joule settings in the rest of the watch. Here I'm just filing off the sharp edges so that when I put the brass in the collet and close the collet, it doesn't mark the inside of the collet. I mean, there's not really a great risk of that with brass relative to hardened steel, but it's a good practice. Okay, the first thing I'm going to do is take a facing cut off the end of the brass just so that it's square. Then I'm going to take the brass down to the correct millimeter. I think we said 2.27 mils. Then I'll cut behind it, start parting it off, and then drill through. Okay, I'm at 2.33, so 6/100ths to go. I gotta say this brass that I bought from Amazon is really not good quality. It's got a sort of grayish complexion to it. And it's actually magnetic, which suggests to me that there's probably some iron in there. So not all brass is created equal, I gotta say. So I gotta get some other stuff, but I'm gonna have to use this for today. Hi guys, so I'm bringing you in for a closer look at where we're at. So I've cut a bushing to the correct diameter. At least I hope it's very close to the correct diameter, and the correct depth. So you can see I have undercut the bushing a little bit. And the idea here is that when I drill it off, it will just come off. So I've cut this part thinner than the drill bit I'm going to use. So I'm looking for a final diameter of 1.15. I'm going to use a 1 millimeter drill. I've cut this down thinner than 1 millimeter. So that way when I cut in, it will just part off the workpiece. You can also see I have made a countersink in the portion of the bushing that will face outward. So next I'm going to use this. What I have here is, here's the tailstock of the lathe, and I've got a collet holding tailstock adapter. So in this I'm going to put my drill, then I'm going to push this thing forward while the workpiece is turning, drill it out, and hopefully I can just part it off that way. So that's the plan. Of course, much could still go wrong, but making progress here. I'm not sure if it's in focus, but it's come off pretty cleanly. So there's a little brass. I guess truly it's not a bushing. It's really more a setting for the jewel. So good, that's a success. So what I need to do now is try to insert it into the watch main plate and make sure that the external diameter is correct before reaming it out to final size and inserting a new jewel. Okay, so here's a close-up view of my two settings side by side. On the right, the old setting. On the left, the new setting. I'm a little concerned that I might be a bit oversized and this one won't work, but you know, just drag back to the drawing board. I'll make another one. Surface finish is okay. I think it could be improved a little bit, but I'm still working on, you know, holding my graver right, applying the right kind of pressure, especially doing female centers like countersinks is quite a challenging cut to get the hang of. So I'm going to try to insert the bushing at left into the plate. The one at right, you can see the exposed jewel is in the old setting is about 0.95. I've drilled the hole to 1, but I couldn't find another jewel 0.95. I'm going to a jewel of 1.15 diameter. So I got to broach out the hole in the setting at left. So I'm going to give it a quick hand clean, and then we're going to go to inserting it into the plate. Okay, I'm now going to insert the setting into the hole in the plate. For this, I'm using my Sights jeweling tool. I just picked this up a week or two ago, and this is the first time I've used it. Up till now, I've used my jeweling attachment for the staking set, but you know, again, to quote George Daniels, it's best to have a dedicated tool for a dedicated purpose. So the setting tool has a micrometer here. So I'm just going to use that to, so I'm just going to use the tool to insert the bushing in. The depthing of the bushing is not that important. I'm going to need depth using the jewel that I insert later. All I have to do now is insert the brass setting into the plate. So here goes nothing. It's my understanding that the way to use this tool is to keep downward pressure and then use the micrometer to gradually push in, lower it. I need some better visibility. There we go. So I just had a nice little lesson, nice little reminder to measure twice and cut once here. I had convinced myself that the jewels I had bought were 1.15 mil external diameter, and I had just got out the reamer. Here's my reamer in the staking set. The Sights also has it, but I'm clearly missing some kind of spindle for that. Whatever. So I got out my 1.15 reamer, and I was about to start, and I thought, nah, I better measure those jewels. And of course, I measure them at 1.1. So had I used the 1.15 reamer, I would have ruined my setting and lost 2 hours of work. So, you know, let that be a reminder to me. So I'm just going to confirm. So I used my vernier caliper, which is pretty good, but I'm just going to use my micrometer here to confirm that I do in fact have 1.1 joules. I'm going to use a little oil as a kind of cutting fluid here, and then I'm going to ream out this setting to the correct internal diameter. Then I'll be able to use my jeweling tool to insert the jewel. That's the plan, anyways. So that's now reamed out to just under 1.1 mils. The reamers don't go all the way to 1.1. They go to like 1.08 or 1.09. Hi guys, so upon reviewing my reaming footage, I realized my camera angle was just piss poor and you couldn't see anything. So I just want to come back and give a little recap of what I did here. So this is a reamer. It fits into a little spindle. These both come with my staking tool. Here's the staking tool body here. The reamer in spindle fits into the staking tool like so. And then you can hold a workpiece underneath to ream out a hole. This is a little stump, and I'll show in a minute how I use that for centering.
A reamer is a cutter to enlarge a hole. It's like a semicircle, a tapered semicircle. On each edge is it's sharp, and then on the backside it's rounded off. So what I did here was I mounted the main plate here. The reason why this stump was handy is because it actually fit in a little recess in the plate and helped me keep the bushing centered. I then came in with my reamer and gradually removed material until I went to the full width of the reamer, which in this case is about 1.09, in which I fit a jewel that's 1/100th over that, so 1.1. It's very important when you're reaming to keep the hole centered and not either allow it to drift off center, or to make worse a distortion that's already there, as you might do, for example, if you're reaming out bushing in a for a barrel that had become distorted over time. If you know that the hole is circular, one thing that you can do, I've noticed, is that since the reamer is in fact tapered, what you can do is find a spot where when you turn the reamer, it makes contact 360 degrees with the inside of the hole you want to ream out. Then you know that the hole is centered and you need to hold the workpiece in that position in order to make the hole wider. There is also a way, you could also do this using a watchmaker's lathe. If you had a faceplate and a cutter, you could perhaps do a better job of centering up your workpiece. But in any case, I've had success just using the reamers that came with my staking tool several times. So sorry again for my poor camera work. I hope that makes some better sense of what I have done here.
Just gonna put just deburr this slightly. Okay, we're back with the sides tool. I've selected anvil and pushers, or stump and pushers, rather. So I'm now going to insert the jewel. Again, I'm not too worried about depthing quite yet. I will deal with that more when I actually go to try to check the end shake of the wheel and check the free running of the train. So right now, my goal is really just to insert this thing. Um, so again, hand pressure and turning the micrometer. There we go, 1/100th more. Okay, our jewel is in. That's great. All right, this is the first time I've ever attempted this. I'm so that wasn't too bad. That wasn't too bad. So okay, I'm really I'm really stoked at having done this properly. So I mean, okay, I'm gonna bring you guys back in for a closer look, and then we'll get on to testing end shapes. Okay, so here's the view after I've inserted the jewel into the setting. So the new one is obviously the one on the left, the old one at right. So I've done my best to mimic the style of the older settings. As you can see, they're not screw settings; they're just friction fit settings. Mine will darken over time, I'm sure, although it will always probably look a little bit different. Um, Also, a dead giveaway will be, of course, that I've used a modern jewel. Old jewels tend to be clear or slightly pink, whereas the new ones tend to be kind of a very dark pink, but that's okay. So, yeah, there we go. That's from the dial side. From the inside, let's see if I can find the thing. Yeah, there we go. So there's the setting. For comparison, there's the setting for the fourth wheel there. So, yeah, not horrible. Not horrible. Maybe not a perfect replica, but not awful. And I'm very happy with that. Hi guys, so I'm now well into the phase of checking end shakes. So what I did at first was just insert the third wheel and try to screw down the bridge. What I found was that the end shake was not sufficient. I couldn't even get the bridge on properly and screwed down. So I had to increase the depth on the main plate side where I put in my new friction jewel. So I did that just again using the jeweling tool as you've seen before, increasing the depth just a few hundredths of a millimeter at a time, until there was some up and down play and the wheel would spin freely by itself. I then added the center wheel because I want to make sure that the two wheels do not make contact. So I'll just show you viewing from the side. We want to make sure that they do not make contact and that the center wheel, and I'm sorry that it's really not very well visible there, is making full contact, like through the whole width of the center wheel is making contact with the third wheel pinion. So that's the case here, and I can now confirm that these two wheels are working as they should together. So if I can just get my blower angled in the right direction here, we can see, yes, there's a lot of freedom for the wheels to spin freely, but there's not too much. You know, I went so slowly that it's really not possible that there's a ton of end shake here, but I can feel with my tweezers a tiny bit, perhaps 1 or 2 hundredths of a millimeter, very, very little. So that's good. That's really good. So now what I'm going to do is I'm actually going to take the center wheel out, and I'm going to put the fourth wheel in, and we're just going to do the same kind of checks of the free interaction or the free running of the third and fourth wheel combination. Okay, so we're coming back in with the fourth wheel installed. So we're checking the interaction between the third and fourth wheels. I should also say that really you should be checking that there's free running both dial up and dial down. So, dial down is the one I really want to check in this case because I replaced a jewel on the dial side, but it's worthwhile checking on both sides. So there we can see, and I hope you guys can see that the third wheel is fully on the pinion of the fourth wheel. And we can check their free running just with the air blower. See if I can get that going there. There we go. So they spin very freely, very little effort. So that's great. Okay, I'm bringing you guys back in for a little wrap up. You can see the jewel that I did, the third wheel jewel in the little, on a lower plane here. That's the third wheel jewel. So you can see my my setting is not a perfect match for the others, but is at least in kind of in the right style. So so I'm going to call it a day on this. So just to recap what I did, I found that the third wheel jewel on the dial side was broken. I pushed out the brass setting. I measured its external diameter. I measured the diameter of the third wheel dial side pivot. I found a jewel that had a correct pivot diameter and was a diameter less than the external diameter of the jewel setting. This was already almost guaranteed because I was over 2 mils. I then cut a bushing in the lathe, inserted it into the plate, reamed it out to the correct size, inserted a jewel, and adjusted the depthing so I got the correct interaction between center wheel and third wheel and fourth wheel in both dial up and dial down positions. So that concludes my repair of this Waltham. Recall that the one other thing that I did was to straighten the bottom balance pivot. I'm hoping that's going to be sufficient, and I won't have to replace the staff, but time will tell. So other than that, this watch is good to go. It really was in quite nice condition, other than the bent staff and this broken jewel. So the watch is ready, has been thoroughly inspected and pre-cleaned, and is now ready to go in the cleaning machine. Okay, guys, thank you so much for sticking around. Thank you so much for watching. If you like what you see on this channel, please subscribe, and I'll be seeing you guys again soon.